All right. So we're going to look at this question. And then in the process of looking at this question, I'm going to use the best response strategy. Okay. We're looking at this question. And I'll use best response strategy. So I'm looking at this question, G1. You have player one, and player one's strategies are A, strategy A, strategy B, and then strategy C. Okay, those are the strategies for player one. Player two strategies are X, Y, and then Z. Those are the strategies for player two. And we know that the first number is for player one, the second number is for player two. We know this. Now, these games show the payoffs matrices of the players. We are going to use the best response strategy, the last approach. And I know that by the time I finish teaching the best response strategy, you're going to love that one more than the iterative elimination. Okay. But then you have to know both. And the way we use the best response is simply by circling the best response payoffs. So what I'm going to do is I'm going to reproduce this data set here for us, okay, in our new information. So let's do that. Let me just create. So in this, I'm going to have a table. Okay. I'm going to have a simple table. And this is a simple table I'm going to have here. And in this simple table, I'm going to have, of course, the first one that I'm going to have here is for player one. Okay. I'm going to have player one here. And at the top, I'm going to have player two. Okay. So for player one, this is the strategies. This is a strategy for player one. And for player two, this is where I'm going to indicate the strategy for player two. And the strategies were given in here as strategy A, B, and C. So I'm just going to write the strategies here, you know, for our purpose. A. I'm going to have the strategies as A, B, and C. And then for player two, he also had his own strategies. And those strategies were X, I'll just take it up here a little bit. X, and then Y, and then Z. Those were the values that we had for those guys. We had X, we had Y, and we had Z. And I'm just trying to just reproduce this information here. Okay, so the first number was 1 and 5, 2 and 4, and then 5 and 1. So I'm going to rewrite that. I'm going to run 1 and 5, 2 and 4. Okay. And then the last one we had was 5 and 1. 5 and then 1. The next one that we had was 4, 2, 3, 3, 4, 2. Okay. So we have 4, 2, 3, 3, 4, 2. And then the last one we had was 5, 1, 2, 4, 1, 5. 5, 1, 2, 4, and then 1, 5. So guys, these are the payouts that we have. We are going to use the best response to handle that. Best response means that you circle the best response. And I'm going to work it out through with you. So this is how we analyze the best response. For player one, you say that if player one goes for A, if player one plays strategy A, which strategy do you think player two will go for? Is it 5, 4, or 1? Who can tell me? If player if player 1 goes for A, player 2 will play what? He will play X to get 5, Y to get 4, and then Z to get 1. Which one will he go for? He will go for 5. Okay, so you play X. So once you identify that, you just circle that one. That's it. You circle that one. You're done with player 1 strategy A. Let's go to player 1 strategy B. For strategy B, if player 1 plays strategy B, which strategy do you think player 2 will go for? X, Y, or Z? Depending on the payoffs, which one will he go for? X, Y, or Z? I'm looking at your answers, so type your answers there. Which one do you think he's going to go for? X, Y, or Z? Okay. You're all right. You go for Y. Why? Because if he goes for Z, he's going to get 2. If he goes for Y, he's going to get 3. If he goes for Z, he's going to get 2. So X and Z don't give him higher payoff, but Y gives him higher payoff. So you circle the 3 like that. Let's go to C. If player 1 goes for C, okay, player 2 will go for what? Now that was obvious. You go for Z. Excellent, Steven. You go for Z. So you circle that 5. So we are done with player 1. Now let's go to player 2. Player 2 means that you rather look at the columns. So if player 2 plays X, oh guys, I've made a, oh yeah. If player 2 plays X, you're now going to look for what player 1 is going to do. Now, I will normally go through that with you, but I'm sure you guys are getting it easy. So let's see whether you can catch it. So if player 2 plays X, which one do you think player 1 will go for? You go for C. Excellent, Mark. You go for C, Janet. Okay, so you now circle the 5. Now circle the 5. Now, what if player 2 goes for Y? What will 1 do? 1 will go for what? 1 will go for what? If player 2 goes for Y, 1 will go for B, which is 3. Excellent. So you go for B, which is 3. That's correct. Because the other 2 and 2 will not help. Last one, if player 2 goes for Z, if player 2 goes for Z, player 1 will go for what? If 2 go for Z, 1 will go for A. That's correct. A will give him 5. Exactly. So when you have done this, you are sorted. You are done. Now, how do you find pure strategy Nash equilibrium using this best response? Now, that question I asked, which one will he go for? What I actually mean is that what will be the best response for the other player? What will be the best response? And using this, we can now find the pure strategy Nash equilibrium. The pure strategy Nash equilibrium is simple. It is given by any cell whose circles are 2. So any cell, any box which have 2 circles, 2 number circles, then that is part of the pure strategy Nash equilibrium. So the pure strategy, before we come to the payoffs, the pure strategy Nash equilibrium is what? What would be the pure strategy Nash equilibrium? Who can tell us? Okay. Which strategies will be the equilibrium strategies? 3-3. That's correct. But we don't, the 3-3 are the payoffs. So we rather say BY, exactly. So you write it like this. You write BY, okay, before you write equal to 3-3. So this is the pure strategy Nash equilibrium using the best response function approach or the best response approach. It's cool. It's very cool. Finish. Okay. So on the basis of this, and I'm now going to show you example 2. So look at this example 2. The numbers have changed. The numbers have changed. I want you to write it on your own, and I'm giving you just some few minutes. Okay. come out with a pure strategy Nash equilibrium for me. Please note that the one we just did some few minutes ago, the one we just did was that the few minutes. It just happens that B and Y, BY gave us a pure strategy. But it could have happened that we would have had two of them. We could have had a situation where this one too was giving us, okay, and this one too was giving us. And then we'll have like multiple equilibria. So I want you to know that it's not all the time it must be one. You can have multiple. All right. So now let me show you the table. And now I'll give you 3 minutes. Solve and come out. When you are done, raise your hand and let me see. And solve for the pure strategy Nash equilibrium using the best response strategy. The best response strategy approach. The best response strategy approach. So let's look at the answer. Okay. Let's look at the answer first. This is the answer, CY. CY is the answer. And I can see that almost all of you have gotten the answer. Let me see. Everybody got the answer, CY, which is 4-3. CY, which is 4-3. Those who actually were honest in raising their hands, they've got it. So this will give you CY. So this strategy, C and Y, this one, let me just see if I can use some means to catch you there. This strategy of C1, that is your pure strategy Nash equilibrium, okay, using this best response approach. Okay, Janet, you have a question. Let me unmute you, then you can ask your question. Yes, Janet, what is the question that you want to ask? What's the question on your mind? Best response strategy.
Okay, Doc.
Go ahead, go ahead.
Yes, Doc, when you are identifying the best response strategy, you realize that at a point we have equal, how do I put this thing?
Yeah, you have this,
then,
you have a particular two strategy having equal numbers.
Yes.
No problem.
You circle both of them.
Yeah.
Okay. Thank you.
So when you have this, like all of them, like let's say I was doing A, okay, and I was doing A, and I was saying that if player 1 plays A, player 2 will choose what? And this number here is 2. And this number here is 2. And this number here is 2. You circle all of them. You circle all of them because they're all equal. They are all, you know, the person will be indifferent in both of them. So that is how you attack these very questions. Now, but remember that it could also have used the iterative elimination of strictly dominated strategy or weakly dominated strategy to find the pure strategy Nash equilibrium. Now, sometimes when you use the iterative elimination, you get to a point where you can't continue further. That is when you use the best response to complete it. And when you're told to use that iterative elimination, use that one. When you're told to use the best response, use that one. When you're told to use both, then remember that you start with iterative elimination, and where you get locked, you can't continue further, you use the best response. Yeah. Now let's look at what I just said with this approach. Okay. So we're going to look at this very example. So look at this example here. You have player 1 playing TMB. Those are the strategies. Player 2 is playing strategies left, middle, right. Okay. And then player 1 is playing top, middle, bottom. So we are going to use iterative elimination of strictly and weakly dominated strategy. And then where we can proceed further, we look at the best response. In fact, we are going to use both. We're going to use iterative elimination to wrap it up. Then we're going to use the best response to wrap it. Okay. So first, iterative elimination. Okay. What you do is that in that one, you are comparing the strategies. Okay. So when you take strategy T, you're comparing to strategy M. And it must be bigger in all numbers for it to be strictly. So if you take, if player 2 plays, sorry, if I am comparing strategy T and M, I'll compare 3 and 2, and I'll see that T is better. I'll compare 2 and 4. I'll see that M is better. So the strict elimination or weak elimination breaks down. So it means that strategy T and M, none of them is strictly or weakly dominated by the other, simply because there was a swap in the second one. Now compare T and B. 3 is bigger than 2. Okay, 3 is bigger than 2. 3, let me get some kind of a pointer so that we can use that rather. So when you look at this 3 is bigger than this 2. When you look at this 2, it is equal to this 2. And when you look at this 5, 5 is bigger than that. So we can say that which is what? You can raise a hand and tell me, or type and tell me. Okay. Between T and B, what would you say? Which is dominated and what kind of domination? Which is dominated and what kind of domination between T and B? I know that elimination approaches can be a little bit daunting for some of you, but you still have to find a way around it. Which is dominated and which by what kind of domination? And some of you are privately chatting me, so use the full chat. So you can see that we don't use the word preferred here. It's domination is what we use. So you got to be clear which kind of one you are dealing with. You have to talk about whether T dominates B or B dominates T, or T is dominated by B or B is dominated, and then what kind of domination. So this one, you can say that B is weakly dominated. Okay, let's be clear in that. Okay, I can say that B is weakly dominated by T. Now, why? Because when you look at the values 3 and 2, okay, and 5 and 1, they were all bigger than B, but the only thing is that they were equal for T and B in the middle section. Okay. So on the basis of that, you can say that T would have been strictly dominated if this 2, if the 2 on top was rather bigger than the 2 below. Other than that, it is weakly dominated by T. Okay. Now let's go. So we've done T and M and then T and B. Now let's go to the M and B. M and B. M and B. So when you look at M and B, the first numbers are 2 and 2. None is better. 4 and 2, M is better. 6 and 1, M is better. So what would you say about M and B? You can type, or let me give it to Morrison. What would you say about M and B? Yes, Morrison.
So I would say that B is weakly dominated by M.
Is it strictly?
No, because the left one, I can see 2 and 2.
So it is what?
Weakly dominated by
M.
M, yeah.
Okay, good. That's correct. So you write that B is weakly, okay? B is weakly dominated by M. B is weakly dominated by M. So we can see that B had to go some way, somehow. By all means, B will eventually go using weak domination. B will eventually go. Okay. All right, so that is for the player one. Now let's go to player two. For player two, look at L, M, and R. So first we do L and M. L and M. So you compare 3 and 2. So comparing this 3 and then the 2. So comparing 3 and then 2. Then you can see that in this case, L is bigger here. You compare 10 and 4. You see that L is bigger. But when you compare 1 and 7, it is rather M, which is bigger. So there is no domination here. Now let's go to L and R, left and right. If you compare 3 and 2, 3 is bigger. Okay. If you compare 3 and 2, 3 is bigger. If you compare 10 and 3, the left is still bigger. But if you compare 1 and 0, the left is still bigger. So what kind of domination is this? Between L and R. Between L and R, what kind of domination is that? Anybody? What kind of domination is this between L and R? Yes, Morrison.
Hello, Doc. So R is strictly dominated by L.
That's correct. That's correct. So you can see that R is strictly, and this is very strictly. R is strictly strictly dominated by L. Okay. And then finally, let's look at M and R. M and R. If you check M and R, you see that they are equal in the first section. M is better in the second section. M is better in the third section. So what would you say about M and R? Let me see some of the answers. Okay, so M is weakly, that's correct. That's correct, okay. So in this case, R is weakly dominated. R is weakly dominated by M. So now that we know this, okay, we can cancel B. Okay, so when you look at B, B can go because B is what? B is weakly dominated if you're going by weak domination. And then when you go to R, R is strictly and weakly, so R will go. R will go, okay. And basically that is it. That is it. So once you do that, you are now back to this section here. Okay. So it means that you're able to do all right with some of them, but not with all of them. So we are now left with this. Once you are left with this, now you're having TM and then LM. Okay, so now let's focus on TM alone. Okay, T and M. Okay, you have 3 against 2. And then you have 2 against 4. There's no domination there. 3 is better than 2, but 4 is better than 2. So there's no domination. Now let's go to L and M. L and M. Okay. Let's compare 3 and 2. 3 is bigger. 10 and 4. 10 is bigger. So we can say that M is dominated here, isn't it? So we can now cancel M using this approach. M is dominated. So M is gone. We are now left with L for the player 2 and then T and M. So now looking at T and M, which one is dominant, is dominating? Looking at T and M. Which one is dominating? Is it T or M? Let me trick you. Which one is dominating? T or M? Just mention it. It's a letter I need. T or M? Which one is dominated? Oh, which one is dominating? Which one is dominant? Let me put it that way. Which one is dominant? T and M. T and M. Type your answer for me. T and M, which one is dominant? Okay, so that is T. So T is dominant. And so because T is dominant, M will go. M will go. M is gone. Okay, and so we can now conclude that our final answer using the iterative elimination alone is this. Okay. The final answer to getting our final result, iterative elimination of strictly or weakly dominated strategy, we are going to have T and then L, giving us 3 and then 3. So that is it. I know that iterative elimination can be somehow a little bit tricky. Okay? It can be somehow a little bit tricky. But we're going to cancel all of this and use the best response as well. Okay? We're going to use the best response as well. So let's see. Best response. Best response. That one is very smooth. Let's see. Now, if you take for player 1, okay, and look at its strategy T, okay, if you look at 3, 2, 5, which one is bigger? 3, 2, 5. Okay, it is what? It is 5. It is 5. So because it's 5, you just circle the 5. The next one for strategy M, 2, 4, 6. Which one is bigger? It's 6. Strategy B, 2, 2, 1. Which one is bigger? It is 2 and 2. We are done with player 1. Let's go to player 2. Player 2, strategy L, 3, 10, 1. Which one is bigger? It's 10. Strategy M, 2, 4, 7. Which one is bigger? It's 7. And then R, 2, 3, 0. Which one is that? It is 3. And so on the basis of this, the best response approach will be for the 6 and 3, and then 2 and 7. The 6 and 3, and then the 2 and 7. So you got to master these strategies. You got to master the strategies. Okay. Any question? Any question? Okay. So the iterative elimination could lead to a different results than that of the best response. Okay. So let's look at this one. Let's look at another example. Let's look at another example of either iterative elimination or best response. I'm going to use a best response for this, and you guys will use it. Best response will be faster here. So we're going to use best response. Best response strategy for this. So you have strategy L, M, R, and then you have AEC, AED, and several other things. Okay. So it doesn't matter. What matters here is that you're going to check. So if you look at L, strategy L, we're going to compare this -1, -1, -1, -1, +1, +1, +1, +1. So which number is bigger? The +1. The +1. So it means that I'm going to circle all of the positive ones. I'm going to circle each one of them. The best response strategy for player 2, Okay. So this is it. Okay, I think the way I got to do it, I've missed it slightly. Is the second one I need to look at. Okay. So if you check this, if player one plays L, if player one plays L, the best response for player two is going to be -1, -1, -1, 5, 5, 5, 5, 5. So we look at from player two. So for player two, the best response will be 5, 5, 5, 5. Okay. Now, if player one plays M, if player one plays M, player two's best response will be the positives and not the negatives, because the positives are bigger. So player two's best response will be 1, +1, +1, +1. Okay, all of those that are +1. And if player one plays R, letter R, the best response for player two will be 3, all the positive 3. Okay, so it's going to be +3, +3, +3, +3. Okay. So now you've seen the place of player one. Now let's go to player two. If player two goes for AEC, which one will player one go for? Player one will go for this 3. Okay. If player two goes for AEC, player one will go for this 3. That's it. If player two goes for AED, player one will go for the -1. And there are 2 of them, -1. The -3 is way lower. If player two goes for AFC, player one will go for 3. If player two goes for AFD, player one will go for the +1. If player two go for BEC, player one will go for the 3. If player two goes for BED, player one will go for the +1, because it's bigger than the -1 and -3. If player two goes for BFC, player one will go for 3. If player two goes for BFD, player one will go for 1. So at this stage, yours is to just look and circle those that have 2 different circles. And they are this one here, this one there, I'm expecting 6, this one there, 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 7. Oh, 7. So you now get what? 7 equilibria using the best response. Let me see whether that's correct. I hope you guys followed anyway. Okay. So let's go to the solution. First, this one has got a solution. There you go. Okay, this is 1. This is 1. This is 2. This is 3. This is 4, 5, 6, and then 7. So that is how you use the best response to be able to look at your work. Now, I want us to take us back slightly to the one we did before. I want to be sure that there was no incongruent thing that I did there that might be too confusing. So I want us to go back to this, using the best response. Okay, I just want us to use the best response approach again for this, because I have this funny feeling I may have missed something slightly. So if player one goes for T, okay, yeah, I missed something, maybe. Let's see. If player one goes for T, player two will go for 5. No. If player one goes for T, player two goes for 3. Okay. If player one goes for M, player two will go for 10. If player 1 goes for B, player 2 will go for 7. Now let's go to player 2. If player 2 go for L, okay, take note. Player 1 will go for 3. I missed it, I think. That's why I decided to do it. If player 2 goes for M, player 1 will go for 4. If player 2 goes for 5, player 1 will go for 6. And so the best response approach is rather this. I think I missed it. And the reason why I realized I missed it is because the iterative elimination of strictly a weakly dominated strategy, it should eventually lead to the same equilibrium using the best response approach. And do you remember, I think one of you asked me the question to explain how the iterative deletion approach, how it ended up with a 3-3. Do you guys remember? And then I went through it with Stephen. And that is what it taught me that no, I need to go through this again. And so it has to lead to the same equilibrium. It has to lead to the same result. Okay. The iterative elimination led to 3-3. The best response will lead to 3-3. Now, so please note that. If we are to go back to the one we just did, this one, and we are to use, you remember we have 17 of them. 17. Sorry, 7 equilibria. If we are to use the iterative elimination, it will lead to the same thing, supposed to lead to the same. But the thing is that probably the iterative elimination will not be able to complete. Let me give you an example. If you look at strategy L and strategy M, which one is bigger? They are equal here. They are equal the second one. Okay. They change in the third one. Okay. So there's nothing. If you look at the next strategy, okay, R between L and R. Okay, R is 3, L is -1, so R is winning. R is -3, L is 1. So you wouldn't be able to use iterative elimination effectively on this. Okay. But again, we've already mentioned that the best response approach, it catches everything. The first strict approach is a dominant strategy equilibrium approach. The second stricter approach or strict approach is the iterative elimination approach. And then the last one, which is quite general, is the best response approach. So that best response approach is what you use and we're able to get this. So this is an example that I will encourage you to go and work. Okay, work it on your own. Do it yourself, okay, and you'll get a solution. This is another tutorial example that you should work on your own and then have the feel. Just use iterative elimination and use the best response approach. Now, I've already told you there will be a situation where the iterative elimination will not be able to do all. Sometimes you'll be able to eliminate some of the strategies. Sometimes you'll not be able to use it to end it. But the best response will always be able to clear everything approach. That brings us to the end of the entire caboodle.